Because they're not saying anything.
Right. Okay. With the recording, I'll send you a link tomorrow with the recording for the people who may miss some of it. Okay. So we go back to the right. Operational problems. We've got some control events, HSE and well control standards. Yeah. So yeah, there was a whole bunch of issues with these tragedies. The main thing is people died, lots of people. In the case of Piper Alpha, 167. Okay? And the reason they died was there were some common themes with all of these tragedies. There was a safety culture, or there wasn't a safety culture. Safety wasn't their first priority, production was. So they kept things going even though an incident had occurred. Okay? Also, communication was poor. So when something happened, right, getting the message across, either people didn't get the message or they just ignored the message when it came through. Procedures, they're there for a reason. They should have been followed, but some people decided that they were going to take some shortcuts, and that led to incidents. Some of these procedures weren't followed because of a lack of risk awareness. People didn't realize what the consequences would be by taking shortcuts. Right? And ultimately, one of the biggest problems we have is with change management. You do things in a normal way, things work okay, but every now and again something happens. So again, with Piper Alpha and actually with a few of the other incidences, there was a change of program, and when they changed the way they were operating, that led to a leak, which followed by an explosion. Okay? So as you go through your careers, please remember safety is the #1 priority. You all have a duty of care to yourselves, to each other. Look out for each other, follow the procedures, talk to people and intervene if you think they're behaving in an unsafe way. Right? Better be safe than sorry. Moving on, again, we're going to have a little bit of interaction here. What I want you to do is guess what the price of oil is going to do, and you put the answers in the chat box. The price of oil can go up, it can go down, or it can stay at the same level. Just put that in the chat box and see what you think is going to happen. In the first scenario, at the bottom we've got time in years, and then we've got the oil price of the day. And the data that we have at the moment is the oil price is what, $2 to $3 a barrel. And it's been going on like that for 15, 20 years. So what do you think the price of oil is going to do in the next 10 or 20 years? Can you put your answers in the chat box, please? Right. Okay. Well, right. Some of you are very optimistic, huh? $50 a barrel. Okay, right. Well, we'll see in a minute what the right number is. About this scenario. So now we've got a 5-year period, and the price of oil has been increasing from $20 a barrel up to $90 a barrel. What do you think is going to happen in the next 2 years? All right. So what have we got? 40. Any other guesses? 50. Okay, any advance on 50? It's already up to 90. So, no. Okay, well, we'll have a look in a minute. And what about this scenario? So now I haven't given you very much information at all. It's just a year, 18 months. And what do you think is going to happen in the next couple of years? Or does everybody think it's going to be $40 to $50 a barrel in every scenario? All right. Do we get any more answers here? Okay. Right. Okay. $90. Keep it at $90. Same trend line. Right. So let's just see what actually happened. So now I've revealed the years, and you can see back in the 50s and 60s, price of oil was constant, it was steady, and it wasn't until 1973, when we had the Middle Eastern War, that the price of oil shot up from, what, $4 a barrel up to 10, and then a few years later it went from 10 to 15, and then up to 35. And these were due to the Middle Eastern wars. And yeah, nobody predicted them. And you can imagine the price of oil going up a factor 10. All of a sudden, you couldn't afford to buy petrol. You couldn't even get petrol. So in some cases, we weren't allowed to drive cars on Sundays. There were power cuts, and there was a real problem in actually just keeping the economy going. Just imagine what would happen if you couldn't afford to fill your car with petrol. And that happened to a lot of people. That was the first scenario. Second one, right, so trend continue, sort of. There was a bit of a drop, and then all of a sudden it went back up again, and then dropped like a stone. So 2008, maybe most of you remember, we had the financial crisis, right? And that had an immediate impact, but then it recovered fairly quickly. But it wasn't at the same level as we had before. You could say on average, well, maybe it was $90 a barrel, but it went up to 140 and it dropped down to 40. So if you're an oil trader, you either made a lot of money or you lost a lot of money. Luckily, most of us are engineers. And for this last situation, so this is quite recent, 2013, 2014, quite high oil price, everything was fine, and then, then we had another crisis, right? Another financial crisis, and that reduced the demand, and it's been hovering at $40, $50 a barrel ever since. Sometimes it drops a bit lower, sometimes it goes a bit higher. So, what can we learn from this? Well, if you go back 160 years, here's the money of the day oil price in dark green. If you convert it to 2016 prices, so I got this from BP, you can see that oil was extremely expensive back in 1860, and then it stayed at reasonable levels until you got to the 70s, and then it went up quite a lot. And recently, it's been quite volatile, right? But also quite expensive. Right. So, what is the impact of a low oil price? So everybody thinks about the negative side of things, about layoffs, projects getting cancelled, not much exploration, reduced rig activity in the sale of assets. On the other hand, sale of assets leads to acquisitions. So it's a way of picking up cheap oil. You've got cheap rigs. You've got more on base business. So you go back to what you've already got. If you've got any projects, when there's a low oil price, that's the best time to actually run a project, because the project costs are much lower and you've also got cheaper labor. But as engineers, the message I want to give you is that we can't do anything about the oil price. our job is about maximizing production recovery and reducing costs. And you should do that no matter what the price of oil is. Now, how do we do that? I've called it Field of the Future, just to be on the Apple bandwagon. I've called it iDreams. It's not trademarked, so if anybody wants to use that. But what we're looking at is in the future, we want safe and sustainable development. We want to optimize recovery, maximize production at the lowest costs, ideally zero emissions. And in order to do that, we need to think out of the box. And the way we do that is something called Well Reservoir and Facility Management, WRFM, and we use something called a value loop. And you can do this for any kind of production or reservoir activity. You take data, right? You build models and you do your analysis, and from that you identify opportunities, risks, and these opportunities and risks you need to sort them out, solve them, schedule and execute them, then learn from what you've done, and that generates new data, and you go around in this cycle. And it could be for production optimization, it can be for reservoir management, for field development, but you need to keep learning from what you do and do it as efficiently as possible, and keep learning. I think that's one of the key things. Whenever you do something, look back and see what you can learn. All right, let's just let Philip in. So, first question we should ask ourselves is, it's the 21st century. Why are we still buying oil and gas? Why should people want to buy oil and gas? So there's a bit of an energy transition, especially in Europe. People are worried about especially emissions. They're also concerned that think oil and gas is dangerous, it's flammable, and generally, especially in populated areas, people are complaining about it being smelly and dirty. There are earthquakes, at least in the North Holland. There's noise, and it's hazardous. On the other hand, they want cheap fuel. It's convenient. It's a lot easier filling up your car with petrol than leaving it overnight to charge up with electricity. High calorific value. So especially for airplanes, that's important. And we can carry on as usual. We can use our cars, our planes, there's power generation, there's plastics and chemicals. So why change? Well, the world is changing, so we need to change with it. And it comes down to global warming and the impact of carbon dioxide in the atmosphere. So that's why people are looking at zero emissions. And to a certain extent, we can already do some things right now in terms of on power stations, there's exhaust gas scrubbers and filters. You can do carbon capture and storage, and you can use CO2 for enhanced oil recovery. So, either for enhanced oil recovery, but you can also dispose of CO2 in saline aquifers. So we can do something with the CO2. And if the CO2 is not going into the atmosphere, then in principle, we can still use oil and gas. Now, if you ask the experts, so for this presentation, I had a look at a whole bunch of energy forecasts going forward. I've got a couple in this presentation. And what you can see here is gas, which is red, and the oil, which is this lower blue one. Right? Up until 2050, people still expect quite a large amount of our energy needs to be supplied by oil and gas. So they're not the only ones. The EIA, they've looked at, so we've got liquids, oil down here in blue, and this time natural gas is in green. In their scenario, they're expecting oil and gas demand to increase with time. Right? Now, of course, all these forecasts have changed as a result of COVID, because there was a drop this year with oil demand. On the other hand, it may bounce back next year when there's a vaccine and the whole world is on full throttle again. So going forward, there's a huge demand for oil and gas. So if we look at the oil side of things, where are we going to get oil from? And we could get it from our existing reservoirs. 2/3 to 3/4 of all the oil in place is still in place. We've actually produced very little of the oil that we are producing from, or the oil fields that we're producing from. We're trying to improve it with water flooding. One of the newer techniques is enhanced oil recovery, although we have been doing enhanced oil recovery for 60 years. But it's taken a long time to sort of take off because it's expensive. People say it doesn't work. They tried it in the past and it didn't work. On the other hand, I was around when we had the same thing, same discussion about water flooding. And once you understand how water flooding works, the same as enhanced oil recovery, you can actually adapt your technique to make it more successful. And basically practice makes perfect. In this scenario, I've shown this carbon dioxide being used for enhanced oil recovery. So miscible flooding, so it's loosening up the oil and removing it so that you get an oil bank. And again, if we've got plenty of CO2, which we have, if we can get it into an oil reservoir, we can get more oil out. And of course, we're disposing of the CO2. On the other hand, we could go into the 22nd century and think about something completely different. The only thing is, what the pictures I've got here, they're all of systems that are currently available. So nanotechnology, and it could be chemicals, it could be microbes, it could be maybe even robots. But just imagine you have something so small, you can inject it into the pore spaces of a reservoir and it will loosen up the remaining oil, or in some cases, it could take heavy oil and break it down so that it becomes lighter and more mobile. Now, for this kind of technology, we need different skill set. This is not your basic petroleum engineering skill set. You probably need some biotechnology or biochemical or bio something, or you need some nano robots. You need a different type of technology. And maybe we should be looking at the medical industry and see how they're attacking cancers, because they're killing cancers with nanotechnology. So it should be easier for us to improve oil recovery with nanosystems. Now, ultimately, so there's oil in the reservoir. We need to get it out. So I think we will still need to have wells. So anybody who wants to be a driller, they still have jobs. On the other hand, it's a little bit old-fashioned to have sort of one location and just drill one hole, even if it's horizontal. I was working in Qatar and we were drilling wells which were 30 or 40,000 feet long, which is great. But just imagine if you could drill a well like this and you could tap into maybe 6 different oil pockets, right? And you've only got one surface location. Potentially you can save a lot of money. And also with the drilling techniques we have now, logging is much more sophisticated. We can actually look ahead of the bit. So we can predict what's happening. So if the formation is going up, where's the oil, right? And can we follow the oil? So we're used to doing geosteering. Can we go oil chasing? The other thing is with wells, whether they're vertical or horizontal, you could think about what's coming out of the well. And quite often in oil fields, the water level is very high. You have water cuts of 90–95%, especially in older wells. So do you really want to lift all that water to surface, separate it, and then dispose of it. What about separating the oil and water downhole? So this is an example of a system that's been developed. It's downhole water separation, DOWS, and we produce the oil from here. There's what they call a de-oiler, because most of it is water, and then the water is injected into this zone down here, and the oil with some water gets pumped up to surface, but there's a lot less water than with a conventional well. And by doing this, you can reduce then the infrastructure that you need at surface for processing, and you're effectively keeping the energy in the reservoir. You can imagine that this aquifer is connected to this oil layer, so you're keeping the energy in the reservoir, so you don't actually have to inject a whole bunch of extra water, which is costing you money. So it all ties in with reducing your lifting costs, your processing costs, also the footprint. And to make this work, you need to have digital surveillance and control. Now, I talked about downhole separation. If you think about facilities, do we really need to have big platforms offshore, big processing facilities on land in people's backyards? Right? What if we can actually reduce the footprint? Right? We go with modular designs which are reusable. Right? They're automated. So an offshore situation, you won't have any platforms. You can just have these subsea clusters, gathering centers, and then the oil gets piped to a central location. Could be onshore or offshore. But effectively, because you modularize this, you keep the costs down. You keep the costs down, then it makes smaller pockets of oil more economic. So you can just produce for a few years, and then you'll take all this equipment and move it to another location. Now, I'm showing my age here. I don't expect many of you have heard of Thunderbirds. This was a children's program back in the 70s, and it centered around something called international rescue. And what they did was they had a satellite listening station which was listening to any Mayday calls anywhere around the world. And if there was somebody in trouble, then this beast, Thunderbird 2, it had capsules and all sorts of rescue equipment was in these capsules. So it just picked up the right capsule for the right job. It could fly in a matter of hours anywhere in the world and rescue people and save their lives. So that was a little bit futuristic, but just ask yourself, imagine fixing any problem anywhere in the world in a matter of hours. Can we do that? At the moment, sometimes it takes us days or weeks before we know we have a problem in a well. And then you've got the logistical problem of working out what the problem is, how to fix it, and then getting the parts moved to the location and the resources to go and make an intervention and fix it. So in order to to fix anything in hours, you need constant monitoring. Right? You need exception-based surveillance. So you have oil fields with thousands of wells. How do you know if they're all working? Well, you need to have them connected up to a network and just keep track on whether they're actually operating. And if you need to fix anything, you want to have standard toolkit available 24/7. So there's an outfit in California called ERA. They work in Bakersfield. They have 15,000 wells, and they have completely standardized everything. They have constant monitoring. When a well has a problem, it's picked up straight away. They work out what the problem is, and a truck drives out the same day in the afternoon to fix the problem. So it is possible. Why can't we make it work on every field? Now, spare parts. Normally, oil companies have huge warehouses full of spare parts, equipment they have bought, and it's just sitting on the shelf, probably rusting away. just imagine you could just print whatever you needed. So this example, this is a turbine, and they've made a small turbine. If they got themselves a bigger printer, they could make one this size. Okay? And if you just printed your spare parts, then you wouldn't need a warehouse anymore. You just need a small factory with the raw chemicals, alloys, whatever it is you're going to be printing with. You wouldn't have to store any parts. You wouldn't have any customs issues, any delivery time issues. Because you're printing it and it's computer printed, it's high quality, it's relatively cheap, and it's fast. So you can imagine, it might take people months, if not years, to make a turbine. Right? If you can do it with 3D printing, you could do it in a matter of hours or days, depending on the size of the equipment. Now, getting this equipment down a well, we're used to drilling rigs, core tubing units, wireline units, electric line units. Just imagine if we had smart tools, which we can just run into a well, right? And if we're going to have more complicated wells, we need to have downhole tractors. And if you're not sure what the problem is, go in with a tool where you've got the downhole surveillance, and it can also fix the problem at the same time. Wouldn't be any issues with hole trajectory. Doesn't matter if they're horizontal, vertical, deviated. These tools would work in any environment, in cased hole and also in open hole. Just have real tractors with tractor tread. And the next step would then be to make them autonomous. So self-thinking, they analyze, they interpret, they see what the problem is, and then they fix it straight away. So what's going to happen to the people? That's probably what you're thinking about, if everything's going to be automated. Well, there's only so much automation you can do. You will still need people to do the analysis, to look at what the computer throws up. All right. I'm going to talk a little bit about artificial intelligence in a minute, but yeah, people will still have to run oil and gas fields and make decisions. You can't completely hand that out to the computer. So we will need smarter people. They're going to have to work with lots of information. When an oil field gets wired up, you could have 10,000 pieces of information coming in every second. So you need the technology to help you filter the information, and then when you've identified a problem, you need to work together to solve it. Right? So there are, you'll have people sitting together in a collaborative work environment. You can see down here, there's lots of breakout areas, because sometimes you just can't solve things on their own. And remember all those incidents I mentioned at the beginning. You need to do your risk assessments and make sure that you've got you're following the right procedures for the right job. Right, so machine learning. Well, remember this value loop that I was talking about. Machine learning does all of this. It tries to learn as best it can. We call it artificial intelligence. That assumes that real intelligence lies with humans. But for machine learning, it processes data, it analyzes options, it's learning from what it comes up with, and we can use it for seismic processing, production optimization. You could use it in drilling for geosteering. The key thing is it's simplifying the process and turning knowledge into petrodollars. So, you're all engineers. How do you make yourself employable? You always need to have a skill set. And if there's a low price of oil, I've talked to a lot of students and young professionals over the years, and they get a bit disillusioned at their first oil crisis. I've been working now, 35 years. I think my first oil crisis was back in 1986. And in the oil and gas business, it happens every 5, 6, 7 years. So the trick is to stay productive. There are still lots of opportunities wherever you are, whether you're in Belgrade or anywhere else. Don't restrict yourself to your home country. There are lots of opportunities in neighboring countries or in other parts of the world. And I've been lucky enough to travel to most of them, whether it's the Far East, Russia, North America, South America, Africa, West Africa in particular is challenging. The Middle East, of course, they've got a lot of oil there. There's oil and gas all over the world. The question for you is, where do you want to go to learn your trade? And be ready for the future. So the things that I told you about, some of them are already happening. Maybe others will happen. There'll be a bunch of things which I haven't talked about, which may happen. So you need to be ready for new technology. And that means just being adaptable yourself, and developing new skills sets. What it does mean is integration and collaboration. You need to work with other people. So cross-discipline knowledge will be very important. You can always put your hand up if you have a question. Hello.
Can I make a question?
Yes, please. It's Milan. Yes.
What is your opinion about inorganic theories of origin of oil, gas, and petroleum?
Sorry, the origins of oil and gas?
Yes, there are in recent times abiotic theories, basically.
Yeah.
Because they found, I think, in Russia and in Vietnam, very deep hydrocarbons, deeper than the granite.
Right. Okay. Well, I have to say, you can find oil and gas all over the place. Most of the oil and gas that we produce at the moment comes from conventional sources. The very deep stuff, how shall I put the unconventional origins of oil and gas. That's going to, if it's very deep, it's still going to be expensive to develop. So you have to ask yourself, is it worth getting after that kind of oil and gas? Right? Or should you concentrate on getting more oil and gas from the existing fields that you have? Now, with the current oil price, I think I'm quite busy at the moment, so I know that most people are looking at what they already have rather than trying to target new discoveries, especially the newer discoveries They're deep water, they're in hostile environments, or they're very deep themselves, and that's going to cost a lot of money to develop. I think there is a place for everything. You just have to work out an economic way of developing those kind of reserves.
Thank you.
You're welcome.
We have another question in the checkbox.
Oh, yes. Go ahead. If the person would like to read the question out.
I'm sorry. What do you think will happen in next few years, considering oil and gas industry?
What do I think? Right. So I'm a production technologist. So normally every answer starts with "it depends." I'm sure nobody knows exactly what's going to happen. What I anticipate is that so the super majors are looking at energy transition, and in fact, the Western world is looking at energy transition and trying to reduce CO2 emissions. So we're going to continue to have a lot of development on renewables. The electric car is taken off. There's going to be a lot more emphasis, I think, on hydrogen. Hydrogen's a bit behind the sort of the electric car system, but people are beginning to realize that if we can find sustainable ways of generating hydrogen, then we can use hydrogen instead of gas. And hydrogen with fuel cells may be a more practical option than going electric. Just imagine trying to fly aeroplanes on electricity, and if they're full of batteries, it's not going to make them particularly light. So you'll see the hydrogen economy picking up, and it's possible that some of the hydrogen will be generated using gas, natural gas. And more importantly, they'll be using the hydrogen and putting it into the gas network, especially in Europe, because the gas goes everywhere. So you can imagine maybe in 10, 15, 20 years, instead of having methane burning, you have hydrogen burning. And it's possible that we are actually using natural gas to generate the hydrogen, but then the CO2 gets re-injected downhole, so there's no net emissions. So maybe it's a wish more than a certainty, but that's a big area of development. What we're also going to see is that when people start taxing CO2 more, then CO2 becomes quite a valuable commodity, and you start seeing now a lot more carbon capture, utilization, and storage projects. So that will pick up, and for this energy transition, yes, we need to have wind and solar. We need to have this carbon capture, utilization, and storage. We need to have hydrogen. We need to have energy efficiency. We need to have it all. And by the way, we will still need oil and gas. So yeah, there's going to be a lot going on. And the questions for all of you is, where do you see yourselves in the world going forward? What do you want to concentrate on? Bit of a long answer. Sorry. Gotcha.
It's okay, thank you. Brian, you have a question?
Yes, may I?
Yes, please.
Yes, I had a question and a comment. Sorry. Yes, about the petroleum, whether there is an alternative. I believe there is no alternative to some other stuff that is made from petroleum in the next 50 years. For example, I haven't seen a feasible enough alternative for printed circuit boards, for example, and I think that will change. And also, if, for example, in now the world that is becoming developed, that was not developed 50 years ago, for example, China, if everybody in China wanted to have a car and wanted to have a hybrid or an electrical powered car, I don't know how much electricity will they need to generate in order for every Chinese person to have a car. But yeah, that is just a comment I wanted to add.
Okay.
And I have two questions. I read recently one article from last year from some gentleman from Halliburton. It's called The End of Petroleum Engineering as We Know It. And it says that in the future, we should expect that petroleum engineering will be more something like observing the processes which are going to become totally automated, from drilling to reservoir, production, everything with sensors, almost everything with machines, and there will be less workforce. I want to know what do you think about it.
Well,
Yes, another is about the modern technologies you talked about and its feasibility. Will it be cost effective in the next, I don't know, 10, 15 years if the price stays like this?
Right. Okay. A few very interesting comments. So let's start off with the chap from Halliburton who thinks that petroleum engineering is going to be completely automated. I can't see it happening. With all the uncertainties that we have, you've got to remember, I've been working 35 years and there are still things that come along and you say, I've never seen that before. I've been on a drilling rig with drillers who've also been working 30 years and they'll turn around and say, I've never seen that before. So with all the uncertainties that we have, yes, computers can maybe make an assessment, but you have to ask yourself, okay, ultimately, when you put all the information together, computers can help you, but are you going to rely on their judgment, right? How do you balance the risk of probabilities? Are you just going to make it a mathematical equation? Sometimes you have to take into account non-tangible information. You have to look at things. Going out in the field, the first thing you'll notice when you go to an oil field is the smell. And depending on the smell, that already tells you if things are running smoothly or not, right? Are there leaks, right? Have you got H2S, right? What's going on? If you go to a well-run gas plant, for instance, you shouldn't smell anything. Okay? You go into an oil field, and I've been to lots of oil fields around the world. When you get you can smell that things aren't right. And yes, can you get machines to do that? Possibly. One thing about the humans is that they have this adaptability. We've been doing it for thousands of years, and we can look at things in a different way, and I'm not sure you can program computers to work like that. So yes, you can use computer technology to help with everything, but there's still a place for people. They still need to make decisions. You imagine being an oil company and say, well, the computer decided that we were going to do this, and then there was an accident, right? So there's always going to be a human at the top of the chain, and the boss at the top doesn't want to be held accountable for everything. So he'll need responsible, reliable engineers below to make sure that all the equipment is working. So I think you'll find the oil and gas industry will still be a human industry. Maybe the skill set that you need is different. There'll be a lot more technology that can help you. The thing is, you're going to have a lot more information that you need to analyze. So there's definitely scope for people. I can't see any oil fields in the next 10, 20 years being completely run by computers. Okay. Right, now what was the second part or the last part?
The second part was about the new technologies and their implementation, how it is economically feasible if the oil is not big. I mean, the price.
Right. Okay. Okay. So first of all, if it's cheap enough, it will be used. So the question is, rather than making, so in the past, what we've done is we've come up with expensive tools for the oil industry because the price of oil was high. Right? Now all of a sudden we need to be a bit smarter and come up with ways of running an oil field much more cheaply. So I'm in Holland, offshore Holland. We have some small gas fields with small offshore mini satellites, right? And some of them are literally just a caisson, a steel pipe with a little deck on top, and they are run on solar panels. And the solar panels generate enough electricity to run those wells and to deliver the gas to the nearby platform. And the amount of electricity they need is less than a heater, less than 2 kilowatts. Right. Because that gas was sitting there, it was uneconomic. The engineers, the humans, have found a way of exploiting existing technology and coming up with a minimum design facility. Right? And yeah, taking that kind of approach, you can apply that almost anywhere. Okay? And then all of a sudden, you can make things economic. Okay? And the same thing, I mean, if you think about this nanotechnology that I was talking about, if it takes off, it's a bit like these vaccines they're making now for COVID. All of a sudden, they can make millions or hundreds of millions of vaccines in no time at all, right? Because there's a market there. Right? And as soon as you go into mass production, the price drops. Right? Now, you mentioned something about China at the beginning. I've been to China a few times. And interestingly, because of their pollution problem, half of the motorbikes, the mopeds that they're using, are actually electrical. Right? So they've been able to get people from bicycles onto mopeds, right, while keeping the emissions down. Right? And the same thing with electric cars. I think in China they have 20 different manufacturers making electric cars. Right? They don't really have enough space on the road for everybody to have a car, right? But you can see what's going to happen. The cars are going to be autonomous, self-driving. You won't own a car anymore. You will just use one when you need it. There won't be a need for people to have a car unless it's for status, because if they want to go from A to B, they just dial it up on their app. It will come to their door. They'll get in. Maybe some other people will get in with them. They'll go off somewhere and they'll be dropped off. If you look at most motor cars, they probably spend 90–95% of their time sitting outside doing nothing. So it's just a change in mindset. Right. So I think that was all 3 questions, wasn't it, Bojan?
Yes, it was. Thank you for your answers.
You're welcome. Right, we still got time for maybe 1 or 2 last questions. Otherwise, do you have a hard stop at 6 o'clock?
No, it's okay. If anyone has any questions, they can ask.
Mm-hmm. Yeah. I mean, I'm already at the beach, so I can stay as long as you want.
Hello, Mr. Mike. First of all, thank you for your presentation. I think it was really insightful on some things like 3D printing. I think that's going to become more and more used in the industry. And first of all, I would like to answer the question you gave us. And I think that oil and gas isn't going anywhere close to. I mean, we aren't going to see drastic changes in the switch of the energy from oil and gas to renewable anytime soon, unless something really drastic happens. And for example, I don't know if you could power a jet plane with batteries, or a transoceanic boat or ship. That would be pretty hard. Mm-hmm. So I think that the future of oil and gas engineers would be to find ways to use oil and gas energy more efficiently, and to reduce the CO2 emissions. Mm-hmm. And the problem is also, I think, with the electricity generation. I think that still in the world, 90% of the electricity is made with power of the coal. So we will still, even though we use green energy like batteries to power car, we still need to make power plants green.
Yep.
So yeah, that's my take on your question.
Mm-hmm. Yeah,
and
like I said, yeah, there are a number of different solutions, and we probably need all of them.
Yeah, and maybe I'd like to ask you, what do you think about the after this coronavirus epidemic comes to an end? Do you think that the companies are still going to practice this at home working, since it's obvious that we all realize that you can actually do a lot of stuff from home too? Right.
Well, I think you really, all of you should answer that, because it's all down to individuals. In some cases, some companies realize that, I mean, if you're building something, if you're manufacturing something, that's not really something you can do at home, right? But in principle, yeah, you can do a lot from home, but you can't do everything, right? So people have realized that they can do a lot of things. The question is, how efficient are they when they're at home? Now, I suspect that most of you are still young, free and single. Right? Well, I have quite a few colleagues who are at home, married with young children, and they definitely have some issues about working at home. Right? It's very difficult with a young family to kind of balance work when you've got a 3-year-old on your lap who wants to play on your computer and destroy your presentation. So yeah, we have an expression in English called horses for courses. So there won't be, it won't swing completely to everybody stays working from home. There'll be a mixture of some people who can work from home, and other people still need to come to work. There'll probably still need to be some kind of interaction. We haven't been very good about the whole networking, the virtual networking. People still, so you can see today, for instance, right, most of you haven't got your cameras on. Yeah, looking at people's faces, looking at their reactions, do they understand what I'm saying with my British accent? So that's still a bit of a disadvantage. So there's still going to be a need for people to socialize face to face. And you know from your own experience, how good is virtual learning compared with being in at the university, talking to people, listening to lecturers, but also talking to other students, sitting with them. Remember, with the computer, we can talk, maybe we can see things, right? But the actual doing side of things is a bit difficult to do that virtually. And I've been very good about not using my hands, for instance, but if you're explaining things and you want to sketch things and you want to solve a problem, yeah, you want to use your body language to do that. So it's getting the balance right. Obviously, if you're doing a PhD and you need to come up with 100 pages, then probably sitting in a small room somewhere and concentrating on that. Maybe that works for you. But if you have to do all your lab work, you have to get information from people, you've got to interview people, you want to see how things work, then I think it's still important that we move around, we network, we travel, we interact with people, because ultimately we are humans and we need other people.
Yes, thank you. I was thinking pretty much the same. Let me turn on the camera for you. Face-to-face interaction.
All right, okay. Thank you.
Well, yeah, I would agree that basically this is a convenient way to work, but it's not actually efficient. For example, if I'm watching an online lecture, it is easy to get distracted with a message, with something else. So yeah, we people are social beings and we like to interact with each other face to face, and this is kind of it's becoming more and more depressing as it goes on to have to interact with people in this way and not be there physically.
Well, it's one of the challenges, right? So also something like this. I mean, personally, I would have been much happier getting on the plane to Belgrade and seeing you all in person, and then possibly having a bite to eat, maybe a drink afterwards or before, during. To a certain extent, yes, we can do that. Things do open up. I've done quite a few of these lectures now, and I'm the program chair for SPE Netherlands, and I organize a monthly program. So we have a distinguished member who does a presentation every month. And what I've realized is that now we're getting something like 100 to 150 people attending those lectures, whereas when we had the face-to-face meetings in a hotel, and people had to pay, we were getting maybe 40 to 50 people, right? And this is in The Hague, right? So distance is a bit of an issue. Maybe cost is. There's the convenience. When we run the virtual lectures, we get people in from around Europe, so it opens things up. And if we get 150 people, if we were in the hotel, it would have been a maximum of 70. So yeah, there are pros and cons to everything, and like I said earlier, we need to be adaptable. Right? This is not going to be the last virus that's going to hit the world. We had Spanish flu, but that was probably, 100 years ago. We had the Black Death. We've had smallpox. We've had Ebola. So, be prepared. Something's going to happen again. Maybe we'll be better prepared. On the other hand, we need to be ready for anything. And, it's not just life, but also oil and gas. And all of you need to be ready for anything.
All right, thank you. Thank you very much for answering.
You're welcome. Any more questions?
May I ask the question?
Of course.
First of all, thank you for the presentation. It was very great and interesting. And you talked about carbon dioxide storing.
Yes.
And what do you think, in your opinion, how much do we need to implement this method of carbon dioxide storing? And how many years would it take to notice results and to drastically reduce the amount of CO2 in the atmosphere?
Right. Okay. I can't give you any numbers. I haven't looked that closely at it. It's not really one of my areas of specialism. What I can tell you is that you're all members of the Society of Petroleum Engineers. The carbon capture, utilization and storage is a hot topic. There's a sort of a technical committee working on it. within 12 months, there are going to be 11 different carbon capture, utilization and storage workshops, conferences held around the world. So it's a hot topic in the oil and gas industry. In terms of the numbers, what I've heard is that maybe CCUS can account for, say, 20% of the CO2, but I don't know if that's like by 2030. That's maybe being a bit optimistic. Maybe it was 2050. The thing is, these are big projects. They're very integrated projects. They're complex. Yeah, they can have a significant impact on CO2 emissions, but it's going to take quite some effort. I think at the moment there are probably around about 50 to 100 sort of carbon dioxide injection projects around the world. So not very many. So yeah, every little helps. The trick is these smaller projects, they need to be done to prove the technique and the proof of concept. And then the trick is to scale them up big time. So you can imagine these smaller projects are getting rid of maybe a few million tons of CO2. Right? You need to scale them up by a factor 10 or a factor 100 before you have an impact on total CO2 emissions. In the meantime, yeah, the electric cars, more renewables, try and use hydrogen. All of these will help with the overall situation. There's no one particular technology which is going to solve the whole global warming. It's going to be a whole bunch of things, and probably the cheapest one and the quickest one to implement is about just thermal efficiency. Look at the houses that you're in. Look at what you're doing yourself. Right. Look at how many miles you travel and what transport you use. If we can reduce the emissions at source, make sure our houses are maybe not quite as warm as they used to be, or make sure that they're better insulated so we don't need as much energy to keep them at the temperature we want. Can you do more journeys on foot, on bicycle, public transport, rather than driving on your own in a car? That's how we can all impact global warming.
Okay, thank you very much.
You're welcome. What do you think? Shall we call it a day? Must be dinner time for everybody.
If we don't have any more questions, we can call it quits. I would like to say that for me, this was a great lecture, and I would like to thank you very much for your time and for this amazing presentation. I hope we'll do some more work in the future with you.
Right. Well, just let me know how I can help. Right, so
of course, thank you. And I would like to thank everyone who joined in.
Yeah.
And that would be it.
Yeah. Thanks very much, everybody. Thanks for all the interesting questions. I really appreciate it. And good luck with your studies. And please stay safe.
Yes. And for everyone, you can follow us on social media, SPE Belgrade, and there you can find all the information about all the lectures and all our projects. Thank you again. See you soon, hopefully.
Okay.
Thank you, everyone. Bye.
Thank you, Mike.
Much obliged.
Thank you.